Hello guys, welcome to my channel. Today we'll be doing some data pre-processing and machine learning over this diabetics dataset. I'll be sharing this code and plus this dataset into my GitHub link, and you can refer that GitHub link in my description. So first we'll be importing some libraries which are like NumPy, Pandas, and some visualization libraries, namely Seaborn and Matplotlib. Then we'll be reading the data set, which is the diabetics data set. Then we'll be loading the first 10 values. To read the first values, we'll be using this head. So this head is used to refer or see, uh, or you can say like if you want to view the first values from your data set, you will be using this head. Suppose if you want to view the last data from your data set, then instead of this head, you'll be using a tail. You'll be using tail. Like instead of dot head, you'll be using dot tail. So that by typing dot tail, you will be getting the last value of that data set. Then we are getting the column names, like you don't know like in the data set how many columns, what are the column name. So to see that, we'll be using this columns. So by typing this columns, you will be getting all the column name from the data set. So next, we are checking whether the dataset has null values or not. So to check the null values or not, we'll be using is null. Then we are checking unique values. For that, we'll be using n unique. Then suppose if you want to know like how many rows and how many columns in your dataset, for that we'll be using this shape, so that we'll be getting an idea about like how many columns or rows in our data set. So in our data set, which is diabetics data set, we have like 768 rows and 9 columns. So columns are like I've said before, right? These are the columns. So there are 9 columns. So then next we'll be seeing like there are 9 columns, right? So we want to know its data type, whether it's integer or string or float or boolean. So to check that, we'll be using this d types. So by entering this d types, we'll be getting data type of each column. So in our case, like we have like 7 integers and 2 float columns. Okay, so BMI and diabetics degree function is float. Others are integer. So next, uh, we are just checking the high blood pressure with respect to age. Like which age has the highest blood pressure. So for that we are using value count. So value count is nothing but to count like how many values are present there. In our case, we want to know like suppose if we take age 20, 20 means like in age 20 like which blood pressure. So there may be some people like in age 20, there may be like 5 people have same blood pressure as 64. So we'll be getting as 5 as a count. So then I have used sort values. There is like we don't need to use sort value, because by using value count, it gets sorted automatically. So there is no point of using sort values. But yeah, I have used like sort values. Then ascending equal to false. If you give ascending equal to false, means it will be sorted based on descending order. Like the highest will be at the first and small will be low. If you're giving true means it will be sorted based on ascending order. So yeah, then after that I have drawn the bar graph for that. So for that, for drawing the bar graph, I have used like dot plot dot bar. Why I have used bar plot means we are just comparing. Like bar chart is used mainly for comparison purpose. So in our case, we need to compare like which age has the highest blood pressure count. So for that, I am using bar chart. So next, I'm just checking like highest pregnancy rate with respect to age. How did the same process here? How did the same process? Like value counts means like you'll be counting the values. Like instead of value count, if you use sum means it will be summing up all the values. Like for example, yeah, it will be getting summing up. Then I have used bar chart. Yeah, so you know that we are comparing. So for comparison purpose, you should use only bar chart, not pie chart or heat map. There are many charts, right? So for comparison, we'll be using only bar chart. Yeah, if you use pie chart also, it doesn't get error, but it doesn't make sense. Like if you're using pie chart, me, it doesn't make sense. Like you can't compare. Like pie chart means what? Like it's a circular shape. So you can't compare easily. You don't get error, but you can't compare. So if you did the same process in bar chart means you can easily compare. Like see in this bar chart, we have like age 21 and pregnancy is 1. So like we have like count as 23. So this is the highest. So from this it's gradually getting decreasing. So yeah, for comparison purpose you will be using only bar chart. By using bar chart it will be easy to understand. So next we are just finding the highest insulin with respect to age. We are doing the same process which we did before for that pregnancy and for that blood pressure. And again we are drawing bar chart for that insulin part. Yeah, then we are just drawing bar chart for outcome. Like outcome column has two values, 0 or 1. 0 means uh, like the person doesn't have diabetics, and 1 means the person has diabetics. So we are just drawing a bar chart to compare like which has the highest value, whether the person has not got diabetics or the person has got diabetics. So from our bar chart, we can come to a conclusion like the person, like we can come to a conclusion that the person who has not got diabetics is highest as compared to person who was affected by diabetics. So as of now, we have done all the EDA part like data pre-processing, data cleaning, but we have not done any data cleaning because we don't have any null values, right? So as you can see, right, we have checked the number of null values, and to our luck, we have not got any null values. So the null values for every column is zero. If you got any like instead of 0, if you got any 5 or 10 or 1, that's in that time you need to do data cleaning. So data cleaning is nothing but like removing the null values or replacing it, or like yeah, data cleaning is nothing but removing the unwanted values or null values. So we don't have any null value, so there is no point in doing data cleaning. So as of now we are done like data pre-processing, and next we'll be uh, building a model which help us to identify the person who has got diabetics or not. So as this problem comes under classification because it's like classifying whether the person has not received diabetics or the person has got diabetics. Either it's 0 or it's 1. So for classification, we can use some of the ML algorithms or model like decision tree, random forest tree, K nearest neighbor, logistic regression, naive Bayes, and support vector mission. So these model or algorithm can be used for classification problem. So first, like we'll be using all this model, we'll be building all this model, and we'll be calculating its score, or you can say as accuracy, and we'll be choosing the model which has the highest accuracy. So if the model has like highest accuracy, for example, if that model has like 90 95% accuracy means it's a good model. Like it can predict in a good way. Suppose if your model has a score like 5 percentage or like 50 or 40 percentage means it doesn't give a good result or it doesn't predict in a good way. So we'll be running all this model and we'll be choosing the model which has the highest accuracy. So first we'll be running our logistic regression. So our logistic we'll be like in our data set we have like independent variable and dependent variable. So we'll be separating data set into independent and dependent. So these are the independent variable and this is outcome is the dependent variable. Next we are just splitting training dataset and testing dataset. Why we are doing this means we'll be using training dataset to train the model. Like if you want to train the model means you need some dataset, right? So that's why we are just splitting it to training dataset and testing dataset. We'll be using training dataset to train our model. So like for example, there is a baby and you have given two photos which is cat and dog. So you are asking your baby to identify like you are giving some two photos which are dog and cat and to your baby and you're asking your baby to classify whether it's a dog or cat. Your baby doesn't know, right, whether it's a cat or dog. So to make our baby to get familiar with the cat or dog photo, we are training our baby. Like we are training our baby by giving some of the dog photos and some of the cat photos. We are saying like this is the dog and this is the cat, and after showing some photos our baby gets trained. like uh, like we are practicing our baby to get familiar with that dog and cat. And after training or after making our baby to get practiced, we are just giving a new photo. It can be a dog or cat, and we are asking our baby to identify whether it's a dog or cat. So our we are giving a dog photo and we are asking our baby to identify whether it's a dog or cat, and our baby is identifying correctly. Why? How it's identifying? Because we have trained our baby to identify it. So that's what we are doing here. We are just first we have just splitted our data set into independent and dependent variable, and from that we are just separating some data for training and some data for testing, and we are using the training data set to train our model. So by training our model, it will identify or predict or classify or classify the new value, new input which we are giving. So that's why we are doing here. So we have just used this sklearn. We are using sklearn package for this machine learning. So we are using like sklearn dot model selection import train test split. So from this we are just from this x and y we are just forming a training set and testing set. So um, after creating a training and testing data set, it's time to create our model. So for logistic regression, we will be giving from sklearn dot linear model import logistic regression, because we are running a logistic regression model. We are so not running, we are building a logistic regression model. So that's why we are giving logistic regression, and we have just trained our model. So to train our model, we need to give a word name fit. So by giving fit, we will be training our model. So now our model has been trained. Then after that, we want to check its score, or you can say it as accuracy. So we have checked the accuracy of our model, and it gives us 78 percentage. It's not bad. 78 percentage is not bad. And after that, we are just giving a new value. In this, I have given a data set, but you can give a new value. So this predict is basically used for predicting purpose. So yeah, we have predicted. So now we have successfully built our first model, which is logistic regression. Next, we'll be building our decision tree. Same thing which I have done before in the logistic regression. These steps, like splitting the independent variable, dependent variable. Then from that, we are forming a training set and testing set. Yeah, in this we need to create a decision tree class, because we are just using now we are using decision tree. So for that we are using, we will be writing sklearn.tree import decision tree classifier. So after that we are training our model. We have created a model. Then in this step we are training our model. Okay, as of now we have trained our model. Next we'll be checking the score. So yeah, this is 100 percentage. So our decision tree has given 100 percentage. So if it gets 100 percentage means it's a best, it's a best model. It can predict easily, not easily, it can predict correctly. So decision tree has given 100 percentage accuracy. Next we are predicting by giving dot predict. So yeah, as of now we have and build, then we have predicted, we have trained, and we have got score, or you can say accuracy for two models, logistic and decision tree. Next we'll be doing SVM, which is support vector mission. I have the same process, independent, dependent, then training and testing data set. Then we need to we have used for SVM, we need to type it as sklearn.svm import svc. So we have created a model, then we have trained our model, and after that we have calculated the score, and it gives us 76 percentage. So as of now, decision tree is at top, which with 100 percentage accuracy. Next, we have predicted. Yeah, now we have completed SVM, and next KNN, K nearest neighbor. The same process, independent dependent variable, training and testing data set. Then for KNN, we need to type it as sklearn dot neighbors import K neighbor classifier. So this n neighbor, like yeah, n neighbor stands for like how many. It's a parameter. So we have given n neighbor as 3. So next we have trained our model, then we have calculated our score. So KNN is giving score as 85 percentage. It's it's not bad. Yeah, 85 percentage. Then we have predicted our model. Next we are just doing random forestry. We have just created independent dependent, same process. Then we have just created training and testing data set and random forestry. So this random forestry comes under ensemble learning. So ensemble learning is nothing but it's like we'll be taking 3 to 4 models, and we'll be running the 3 to 4 models, and for each model we'll be getting some values. Like after predicting, we'll be getting value for each model. So we'll be collecting all the result of each model, and we'll be seeing which which has the highest majority. So the highest majority wins. So that's what ensemble learning. So random forestry is nothing but we'll be taking like 4 to 5 decision tree randomly. We'll be selecting randomly 4 to 5 decision tree. Not, it's not like 4 to 5. You can choose you can choose as many as decision tree you want. So we'll be selecting like a random decision tree. Suppose like we are selecting like 10 random decision tree, and each decision tree gives a predicted value. So we are collecting all that predicted value, and we are checking the majority, like which result has given the highest majority, and we are choosing that result. So that's what random forestry. So we have just wrote like sklearn.ensemble because random forestry comes under ensemble learning. So we have just wrote it as dot ensemble import random forest classifier. So so this then we are just building our model random forest classifier. Here n estimate is like how many decision tree you want. Like I have just typed like 10. Like I'll be using 10 random decision tree. Then criterion equal to entropy. Like we can use entropy or Gini index. So I have used like both entropy and Gini index. Gini index is default. So we have like entropy and Gini index. So I have used both, and I have checked both score. So for yeah, for entropy, we are getting like 98 percentage. So this yeah, this we have trained both. We have trained both model, and then we have checked both score. We are getting 98 percentage for entropy and 97 percentage for Gini index. Then we have predicted for each model. Then we are building a naive Bayes model. So yeah, here we have just splitted independent, dependent. Then we have just created a train and test data set from these um, independent, dependent variable. Then we have just built a naive-based model, and we have trained, and we have got score like 75 percentage, and we have predicted. So far we have like built, and we have trained, we have predicted, as well as we have got some score for that model. So as I said before, the model which gives a higher score will be selected, because the model which has higher score gives the good prediction. So logistic regression gives 78 percentage, decision tree gives 100 percentage, SVM support vector machine gives 76 percentage, K nearest neighbor gives 85 percentage, random forest tree if its entropy means 98 percentage, if its Gini index means 97 percentage, and naive Bayes is 75 percentage. So from this we'll be choosing decision tree because it has given 100 percentage accuracy. So we are choosing decision tree. So Yeah, that's it about it. Thank you.